The null hypothesis, written capital H subscript 0, the null hypothesis, H sub 0, what that is your assumption about the parameter. Your null hypothesis is your assumption about the value of the parameter. You assume this is true and you build a chance model based on that assumption. It's the by chance alone explanation. It always has an equal sign. So at the beginning of your simulation step, you say, all right, let's assume pi is equal to 30%, or let's assume mu is equal to 270. You assume the parameter equals something, and then you build a chance model based on that. It will show you what the sample statistics should look like if that assumption about the parameter is true. So I have some examples written down here about how you'll actually go about writing a null hypothesis. Always, when you write a null hypothesis, the way you write it in symbols is like this. You write capital H sub 0 colon, which is read, the null hypothesis is as follows. Then you write the symbol for the parameter. This will be either pi or mu for the bulk of the semester. And you then write equals whatever value you're assuming. For example, the null hypothesis is as follows. Pi equals 0.8. The way you'd say that in words is, the null hypothesis is as follows. The proportion of success in the population is 80%. Another example, in symbols, we might say, the null hypothesis is as follows. Mu is equal to 13.2. The null hypothesis is as follows. The population mean is 13.2. So in symbols is the one over on the left, and in words over here on the right. Now, actually, when you actually write it in words, you'll actually say it in context. Like you'll talk about percentage of Skittles or the mean GPA and so forth. So we'll do that again when we get down to the examples. So the null hypothesis is the hypothesis with an equal sign. It is the thing you're assuming is true in order to build your chance model. You're also going to have what's called an alternative hypothesis. The alternative hypothesis is basically the opposite of the null hypothesis. It is the other thing that could be true. Remember, we're going through all this to try to figure out, does this null hypothesis assumption about the parameters seem like it's correct and true, or is it wrong? The alternative hypothesis is kind of the other explanation, like the null hypothesis is wrong. This is actually the opposite of that, and this is what seems more true. So the alternative hypothesis is the opposite of the null. At the end of the problem, you're either going to say, yeah, the null seems plausible, or the alternative seems more true. So the alternative hypothesis will not have an equal sign. The alternative hypothesis will always have either a less than symbol, or a greater than symbol, or a not equal to symbol. It's going to say pretty much exactly the same thing as the null hypothesis said, but just opposite. So let's jump down here. So up here in the null hypothesis, in the previous example, we had said the null hypothesis is as follows. Pi is equal to 0.8. The alternative in that case might be, no, it's not equal to 0.8. The alternative hypothesis is as follows. Pi is less than 0.8. So we would say the alternative hypothesis is as follows. The proportion of success in the population is less than 80%. It might have been that the null hypothesis was that mu equals 13.2. So the alternative might be then that mu is actually greater than 13.2. Please note, how do you figure out if it's less than or greater than or not equal to for your alternative? The way you figure that out is from your actual research question. Your research question would have originally posed a problem like, you know, my friend said that Skittles are 40% red, but I actually think there's less than 40% red. So you would be testing whether they're equal to 40% in the null hypothesis or whether they're less than 40% in the alternative. And another way to say it, maybe your friend says the GPA of students is 2.7, and you actually think it's not 2.7. You don't know what it is, but you're pretty sure it's not 2.7. So in that case, the alternative would be that mu is equal to 2.7. The alternative would be that it's not 2.7. You don't know what it is. You just don't think it's 2.7. So you'd use a not equal to in that case. So you figure out if it's less than or greater than or not equal to based on the research question.